Ladies and gentlemen, up next we have an interesting panel discussion. It's on tri-service plans for self-reliance. For the session chair, we have Major General C.S. Mann, PVSM, AVSM, VSM, Additional Director, General Army Design Bureau. Please give him a warm round of applause as we welcome him on the stage. He has been an instructor of automotive technology at Armed Corps Center and School. He also earned distinction in tank technology course. He's attended the Defense Services Staff College and the Higher Defense Management course. The officer is currently heading the Army Design Bureau and is a key facilitator of indigenization and infusion of niche technologies in the Indian Army. So we heartily welcome you for this session. On the panelist, may I now request Air Commodore K. Giri, VSM Commandant, Air Force Technical College, to please join us on the stage. Please give him a warm round of applause, everybody together. Captain Sanjay Sharma, retired Indian Navy, to please join us. Brigadier Alok Jain, SM DTE of Indigenization, Indian Army.
Respected veterans of ELCINA, you can see here many veterans, the serving officers, veterans, my brother officers, industry partners, academicians, researchers, ladies and gentlemen, good afternoon and Jai Hind. Jai Hind. Jai Hind. You know, it's a very daunting task for me actually. Immediately after lunch and conducting this session, anyway, keeping everybody awake and attentive is, I think, not only for me but for all the panelists to see that how we are able to carry on with this session. Okay. At the outset, I would like to express my gratitude to ELCINA for having given this opportunity to present our requirements and the way the services are looking at self-reliance. This very topic itself, the tri-services plans for self-reliance. When we look at self-reliance, there are two perspectives to it. One is in terms of import substitution, or say indigenization of the legacy equipment which we have generally imported. That is one aspect. The second is, what about in future? Whatever we are going to do in future, whether that is indigenous or not, that is where again the self-reliance comes in. So what I am going to cover in my part is the latter part, because for the first part, import substitution, we have here Brigadier Jain from the Army, who heads the Directorate of Indigenization, which is his primary task, so he shall be covering on that part. Now, if we look at, say, the tomorrow's this thing, so therefore what we are going to cover is the needs of the armed forces for tomorrow's battlefield. And when we look at tomorrow's battlefield, just a very simplistic graphical representation. You look at any of these weapon systems platforms, may it be right from, say, communications, whether SATCOM or, say, laser communications, may it be in terms of sensors, whether EO, IR, RF, may it be in terms of, say, the guided weapons, the counter systems, like, say, jammers and EW systems, and anything, whether it's navigation, there's not even, I think, one system which does not contain electronics in it. So that is where the importance of electronics comes in. And I think with that, if we see, it may not be incorrect to say that the next war will not be decided only by the number of tanks or, say, artillery guns or aircrafts or ships we field. It will also be decided to a very large extent in the EM spectrum. So therefore, and I think it will not be wrong also to say that the spectrum is emerging as the another front line. But why do I say that? You know, during World War, there was something called, what is shown here as OODA loop, which was evolved by Colonel John Boyd, who was basically an aircraft pilot. And he said that his abilities, effectiveness depended on how faster this loop gets closed. It's observe, orient, decide, and act. Now this loop over the years, because that was primarily based on the visual thing, or say later on with the help of vision devices and all. But today, what it has got transformed into is something called as kill chain. Because now it is a sensor shooter link. And this kill chain, the faster, the more responsive it is, the better is the performance of the system and that organization as such. And of course, all this requires secure communications. And that is where I think the spectrum is emerging as the new front line. Now, if we see that in that context, in fact, the events like the Strategic Electronics Summit, it is no more, say, merely a supporting agency, but it's a potential combat multiplier. And for India's journey towards Viksit Bharat, it will succeed only if we achieve technological sovereignty in RF, microwave, millimetric wave, and spectrum warfare technologies. So the battlefield is, if we see now, transforming at machine speed. So this is the point now for all of us, right from the user to the researchers to the industry. Our development cycles cannot really move at the file speed, which has been the case so far. So we all need to, that way, transform to be able to be on the technology curve. Okay. And what has been learned from all these recent conflicts, the operational reality is that one pattern is totally unmistakable. What? The spectrum is contested right from the minute one, right from the moment go. The drones appear in swarms and not singles. Communications are jammed early. GPS is denied or it is unreliable. So therefore, the battlefield is rapidly shifting towards distributed RF sensing grids, UAV-mounted payloads, soldier-borne sensors, millimetric wave high-resolution detection, W-band and emerging terahertz applications. But as a soldier, a primary thing which especially for the army, which remains applicable is that what is experienced by the field formations is that all these electronic systems are too large, or they are too power hungry, or maybe they are too platform bound and too slow to configure. Whereas what we need is low swap, low size, weight and power requirements and rapidly deployable systems. I think that is where the entire challenge in electronics lies for the Indian industry, especially for the systems to be developed for the armed forces. So I'll now highlight where core electronics domains can become actually combat multipliers in terms of, say, what the technological requirements are or the gaps are, purely from the Indian context, and also based on our global scan, what is happening around the world, so that we remain on the technology curve. Now, first aspect coming on to the communications, the high data rate communication beyond line of sight and over the horizon links, they are traditionally based on HF, satellite, airborne repeaters and troposcatter communication. However, these suffer from various constraints, such as channel capacity, reliability, energy efficiency. So therefore, there is a requirement of a development of a flexible solution which may switch between multiple options. High capacity backhaul connectivity in the range of 200 to 500 Mbps, enabled through communication repeater payloads on satellites and high altitude pseudo satellites, that's HAPS. This will be really critical. And these payloads should leverage high throughput RF and optical feeder links, steerable high gain antennas, and adaptive modulation to relay voice, data, and ISR traffic between the dispersed forces and the core networks. The second one, the last one shown here on the slide, direct to mobile SATCOM. So say using 3GPP aligned waveforms and spectrum coordination, these systems can integrate space and cellular networks to deliver ubiquitous connectivity for emergency services, disaster response, maritime or remote users, and defense operations. Okay. Now, another major challenge. We have radio sets all, say, inducted in different timelines from different sources. So, with a view to achieve a cross-domain solution for radio communication, a tactical data link can be adopted to ensure seamless interoperability among diverse radio systems operating in the tactical battle area. Now, such a TDL, it should act as a common digital layer that bridges heterogeneous waveforms, frequency bands, and platforms, whether land, air, and maritime, thus enabling secure, real-time exchange of voice, data, and situational awareness. So by supporting standardized messages, dynamic routing, reduce sensor-to-shooter timelines, and thus ensure coherent command and control in complex multi-domain battle environment. Another aspect which is emerging is the high-frequency communication links in the E-band, 71 to 86 gigahertz. They offer really a promising solution for low probability of intercept communications. The combination of their pencil-thin beams, adaptive modulation, rapid beam steering, and low side lobe emissions, they enhance the stealth and resilience against electronic surveillance and jamming. Okay. Another aspect, the frequently deployable QKD. It is a critical enabler for future-proof, tamper-evident communications in defense, strategic infrastructure, and critical command networks. Battlefield futuristic 6G, military-grade private networks. They will provide a resilient, ultra-low latency digital backbone for multi-domain operations by tightly integrating terrestrial, aerial, and space-based nodes. Say by leveraging sub-terahertz bands, AI-native network management, network slicing, and integrated sensing and communications, this private 6G would enable real-time ISR fusion, autonomous swarm control, extended reality command interfaces, and secure machine-to-machine coordination at the tactical edge, thus compressing the sensor-to-shooter timelines. Now, EW, cognitive EW is what the future is heading towards. But for this, I think the key enabler for this is the optical processing of RF signals, which enables ultra-wideband reception, that is from 1 megahertz to 40 gigahertz. And that is what by mapping electrical RF spectra into the optical domain, where photonic components offer extremely high bandwidth, low loss, and immunity to electromagnetic interference. Now we all know that the satellite-based ESM and ECM, they provide persistent, wide-area electromagnetic surveillance and influence from space unhindered by terrain or the national boundaries. However, the emerging aspect is of the high-altitude platform systems, that is HAPS, which are operating in the stratosphere. They offer a unique middle layer between satellites and airborne platforms for ESM and ECM missions. With their long endurance and quasi-stationary positioning, the HAPS can be combined to provide persistent regional spectrum monitoring, precise emitter localization, and responsive electronic attack with lower latency than space-based systems. Now further, cyber over RF payloads, it exploits wireless links as a vector to deliver cyber effects, thus bridging the electromagnetic and cyber domains. Now, such capabilities, obviously they enable non-kinetic effects like data corruption, command disruption, or system degradation, thus expanding the EW from signal denial to deeper cyber-physical influence on adversary networks and platforms. Okay. While we have all the communications, simultaneously the jammers are getting developed. So next generation follow-on jammers. For advanced jamming requirements, they must counter the high agile frequency hopping systems, employing at least 15 concurrent hopping patterns with hop rates exceeding 3,000 hops per second. And achieving this demands ultra-fast wideband sensing, AI-assisted hop prediction, and low-latency digital or photonic RF generation to enable effective and proactive jamming. Okay. In this regard, so far as EW is concerned, what we have experienced, especially during Ops in Dur, at present, there is a very critical need for a dedicated electronic warfare testing range for our indigenous drones. And I think that is where, again, maybe ELCINA can look at how we can get the sources of the industry and the government combined. This EW testing range should enable the systematic validation of command and control links, navigation resilience, sensor performance, autonomy algorithms, and fail-safe mechanisms under controlled yet operationally representative conditions. And if once developed, it could also support the development of indigenous counter EW techniques, spectrum agility, anti-jam waveforms, and hardened payloads, thus reducing our dependence on foreign validation facilities. Another important aspect is that the requirement of medium caliber proximity fuses, whether it be in 12.7 mm, 23 mm, and 30 mm. But this has really grown significantly due to the evolving nature of battlefield threats because of the drones and all associated equipment. Because it is these proximity fuses which enable the airburst detonation at an optimum distance from the target, thus substantially increasing the hit probability compared to the point detonating fuses for obvious reasons. Okay. Advanced antennas. Now they are a cornerstone of next generation warfare, as they are the ones which directly define the range, stealth, and survivability across the electromagnetic spectrum. So technologies such as ISA, conformal and embedded antennas, digital beamforming, and multi-band or multi-function apertures, they enable highly directional, agile beams with low side lobes and rapid reconfiguration. Thus, these capabilities, they support LPI/LPD communications, adaptive EW, integrated sensing and communications, and resilient operations in jammed or contested environment. Terahertz. The exploitation of terahertz frequencies from 0.1 to 10 terahertz in defense will actually offer transformative advantages across sensing, communications, and electronic warfare due to their unique ability to combine high resolution with directional propagation. Okay. From a military perspective, controlled exploitation of terahertz technologies, it will enhance situational awareness, improve counter-stealth capabilities, and provide asymmetric advantages while posing new challenges and opportunities in spectrum dominance and future electronic warfare. Anti-radiation sensing is a critical capability which needs to enable the detection, classification, and geolocation of hostile electromagnetic emitters. Actually, it forms the backbone of electronic intelligence, electronic support measures, and support or destruction of enemy air defense operations. So with the increasing use of agile, low probability of intercept waveforms, and mobile emitters, with advanced anti-radiation sensing, integrating AI-based signal analysis, multi-sensor fusion, and distributed platforms is very essential for maintaining the electromagnetic dominance. Okay. Quantum warfare, we all are aware about its applications, may it be say in terms of sensing, navigation, computing, and communications. However, one important aspect I would like to highlight here is, again, a point for ELCINA, the requirement of a quantum testing lab, especially for the military. We faced this problem when we wanted to actually induct quantum key distribution. For nearly 1 year, there was no means of testing it, whether it is actually quantum or not. So this is something which is required, and if we have this, along with the testing standards to validate and ruggedize the quantum sensors, may it be for navigation, timing, gravity, and magnetic field detection, and quantum communication systems, that is QKD and quantum secure networks, and also for post-quantum cryptographic solutions. Okay. Now, when we talk of ISR, two aspects in this only I would like to highlight. RF-based battlefield sensing, which is beyond the traditional radar. It exploits the ambient and adversary electromagnetic emissions, such as communications, broadcast signals, and an important aspect, unintended RF leakage, which achieves situational awareness without active transmission. So basically the advanced signal processing and AI-enabled fusion of weak, diverse RF signatures into actionable intelligence. Now, as a result, this passive RF sensing, it provides a stealthy, resilient sensing layer well suited for the contested and electronically denied battlefields. Quantum sensing, or they can significantly enhance our ISR capability. Quantum gravimeters and magnetometers, they can enable passive detection of submarines, underground facilities, and concealed infrastructure. While on the other hand, the quantum inertial sensors, they provide high accuracy navigation and targeting in GPS denied or contested environments. The silent killer, EMI, EMC, it's a silent kill chain. Now today electromagnetic vulnerability is a combat risk and not just merely a compliance issue for the purpose of EMI, EMC testing during the procurement process. It's actually a combat risk. Why? Because the failures in this, they lead to intermittent communication loss, unexplained sensor degradation, navigation drift, and mission computer resets. So, and as the platforms like FRCV, light tank, LCH, ALH, advanced this thing with the WSI and all, they become electronic dense. The threat from EMI and EMC also grows correspondingly very rapidly. So therefore, what we must now push is towards design stage EMC integration, battlefield representative test profiles, predictive electromagnetic modeling, and faster certification cycles. In fact, what we have experienced is that when the vendors bring up their equipment for testing, that's the time they realize that it is not EMI, EMC compliant. Then they start hardening it for it, which takes another time and of course affects the entire design also. So from that aspect, EMC must become a design religion and not a post-design ritual. I repeat, EMC must become a design religion and not a post-design ritual. So finally, if we look at it, that India has built a strong technological foundation, but the next phase will be unforgiving. And future wars, they will reward nations, not just militaries. Again, I repeat, future wars will reward nations and not just militaries who achieve what? Spectrum dominance, electromagnetic resilience, rapid technology iteration, indigenous RF depth, and cognitive EW superiority. And I think towards that end, again, Strategic Electronics Summit has the competence to become a national center of gravity in strategic electronics. So far as we are able to address the major challenges, primarily for the Army specifically, while Air Force and Naval officers will give out from their perspective, miniaturization, I've already highlighted in the beginning, optimum swap, wide temperature ranges, at least from -30 to +50 degrees centigrades, and wide range of atmospheric conditions across deserts, jungles, high altitude, etc. Now in all this, the Army Design Bureau stands to work shoulder to shoulder with you. We are there to handhold. Now for that, what is required is, what are our exact requirements? While I have given you a broad technology perspective, what is emerging, but coming on to specifics, now we keep releasing various documents from time to time. What is shown here on the slide are these three documents. One is Technology Perspective Capability Roadmap. It's a tri-service document. The second one is Compendium of Problem Definition Statements of Indian Army. Third one is Compendium of Technological Challenges. Now these documents are available online. You can just Google for these documents. For example, the TPCR lists out these kind of equipment which are primarily electronic heavy. CPDS, it gives out various domains as shown over here in the pie chart. And the last one we had launched was during Aero India. We received good about nearly 800 responses, both from industry and academia. And accordingly, from that, nearly for 50% of them, we have already initiated various R&D, D&D projects or procurement cases. R&D, D&D projects supported, funded by the Indian Army. Just to give you an idea of Compendium of Technological Challenges, this is what is available online. Anyone having any interest in any of these challenges, 23 of them are still open till 31st of July. They can reach us through the email given here on this slide. While I spoke of all this for the new technologies, one aspect I mentioned initially for import substitution, during various events like Aero India Def Expo, we do display, the Directorate of Indigenisation displays these various equipment components across the entire range, may it be say like engines and all in mechanical, hydro-mechanical, electrical, electronics, vision devices, ammunition, communication equipment, so that industry can get a feel of it and you realize it for yourself, whatever fits into your bucket, where you can actually try to help us in indigenizing those components. The latest document, we have released this Indian Army's technology roadmap for unmanned aerial systems and loitering munitions. It covers 30 different types of the drones and the loiter munitions under these different heads. Again, this document is not available online because we need to maintain some amount of confidentiality in this. So this document can be accessed, but there is a method. I'll just show you in the next slide. Just to give you an idea, well, some data over here has been masked intentionally. When you receive this data will be there. It gives out the broad overs and our quantity requirements, exactly what the Indian Army is looking for, so that you can start preparing for these equipment. And whenever the RFI, RFPs are generated, then you can participate in those. This is how you can access this. You have to go through a process so that the credentials of the industry are established, and we sign a non-disclosure agreement. We share with you only those specific pages as per your domain. And then you can start looking at developing those. Okay. While all this is giving the requirements, but when you are developing, even at that stage, we do handhold. I will say even before that, what we've experienced is that especially the industry from the south, they're really not able to visualize the kind of operational conditions, the terrain and the environment we have on our northern borders, especially in the high altitude. A very simple example, people come to me, they say, sir, my drone can fly at 6,000 meter altitude. I ask them, where have you tested? Obviously, they say, sir, Chennai, Hyderabad, Bangalore. That is not where the challenge lies. From here, the drone can go 6,000 meters. But when it has to take off from 4,500 meters or 5,000 meters, that's where the whole challenge lies. Some of those drones are not even able to take off, or just take off a few meters and fall down. So unless those who have to develop this equipment actually understand, they experience those kind of terrain and weather conditions over there, they may not be able to do it. So therefore, to facilitate that, what we are doing is that we are conducting the forward area orientation tours, and industry and academia have been going for this. This is not working now. Yeah, I'll just come back to this. Forward area orientation programs, so that the industry can actually experience that, and based on that, it is like, sort of a, say, collaborative development. People then come back to us, those who had gone there, sir, I had experienced so-and-so problem over there, I have this solution for you. And that is how then we further guide them and take them through for the development. And in this development process, you see there are various routes available today, right from an individual innovator to the government agencies like DPSU and DRDO. And with the funding, right from 1.5 crore to 250 crores per project. And this is what it just gives out in what route, how much of funding is there. I'll not go into the details. I think it's quite self-explanatory. You can see it once, since most of you are clicking photographs. Okay. And just to showcase to you that how Indian Army is trying to get everything indigenous, our self-reliance, and also trying to build up the ecosystem. As of today, we have nearly 574 projects worth about nearly 2,32,000 crore. That's the market value of these, only the R&D projects and not the procurement cases. They are separate. And involving good about nearly 650 odd industries. And if you notice in the pie chart, the sum total of MSMEs and startups itself goes to about nearly 54%. So that is how we are endeavoring to get this Atmanirbharta and develop the ecosystem. And once industry is developing, should you require your internal validations before you offer the equipment to the army, you're most welcome to approach us. We will send you to the areas of envisaged employment of that equipment. Obviously, things like high altitude areas which are not accessible to you. You have to just go there and then test your equipment. Our troops are there on ground with you. As a result, they're able to tell you as to what are the shortcomings in that, or what all kind of product improvements if you carry out, the equipment may be more acceptable to us. So that is how, again, a sort of a collaborative development, and we are assisting in that. Okay. And whenever range is required, ammunition for any that kind of thing, that also is being provided to the industry. The no cost, no commitment demos, people generally feel that it does not result into anything. Here are the figures just to indicate to you in about last 3-4 years. Based on these NCNC demos, these equipment have been procured by the Indian Army, which were otherwise not part of our annual acquisition plans. Worth about nearly 4,400 crore plus through the central procurement, and about 1,250 odd crores through the delegated powers at the Army Commander level and below. Okay. And also we do assist industry in the export promotion by virtue of any military delegation coming to India. I brief them for about half an hour on the indigenous defense capabilities of our industry. And we also, during our exercises with the friendly foreign countries, we invite the industry to come and showcase your products to those foreign delegations. Events like the last one we had in October, this was a UN troops contributing countries chiefs conclave, wherein from about 38 odd countries people had participated and equipment was displayed. So that is how we are trying to achieve our Atmanirbharta and also assist the ecosystem to grow. And with that, I come to the end of my part, and now I will hand you over to the next panelist. Before I request him to come up, I will just introduce him. Brigadier Alok Jain, Sena Medal. He's from the core of EME, that's Electronics and Mechanical Engineer, with over 3 decades of service. And he's an accomplished academician. He holds a specialization in radars, an MTech in electronics, and a PhD in management. And throughout his illustrious career, he has had several key appointments, including Chief Maintainability Engineer, where he was responsible for the maintainability of the missile systems of Indian Army. And he has also commanded the 515 Army Base Workshop. All of you being from Bangalore, I'm sure most of you know what it is. And he's had exemplary service even during counterinsurgency operations, where he's earned the Sena Medal and several commendation cards also. And in his present role as the Directorate of Indigenisation, he is spearheading the Indian Army's efforts to strengthen indigenous defense capability. The Directorate is driving the development of indigenous solutions to replace imported spares, sub-assemblies and assemblies, thereby enhancing operational readiness while advancing the national vision of Atmanirbhar Bharat. So with that, now I request Brigadier Jain to please come up and share your views.
Distinguished guests, industry leaders, innovators, academia, representative of ELCINA, ladies and gentlemen, Jai Hind. Jai Hind. Yeah, thank you. It's my proud privilege to address the esteemed gathering here at the 15th Strategic Electronics Summit. I must compliment ELCINA for its visionary role in developing this ecosystem to support the defense industry and the aerospace industry. As we move ahead, India today stands at a defining moment in its journey towards strategic autonomy. The vision of Atmanirbhar Bharat in Army is just not an aspiration now. It's an operational reality. The Indian Army, as it's the largest user of defense industry, is totally committed to partnering with the defense industry in its journey towards Atmanirbhar Bharat. Now, as we all know, the global security environment is evolving rapidly. The emerging technologies, contested supply chains, prolonged conflicts have highlighted the critical importance of indigenous capabilities. For a nation of India's stature, the operational readiness can't be dependent on external sources for the supply of spares, sub-assemblies, assemblies, or technologies. As far as the new technology is concerned, we have progressed a lot. But the challenge lies in sustaining our vast legacy platforms. As in the morning session, our Director General Sahani has brought out that almost 70% of the equipment of the Indian Army falls in the category of the legacy systems. Now, these legacy systems are going to stay here. It is not that we are discarding it or we can replace it just like that. They are going to stay here for years. So, there is a requirement that we find out solutions. We develop the innovative indigenous capabilities so that we can sustain, upgrade these legacy systems, and we can have a obsolescence management for them. Now, when we expect you to collaborate with us, but at the same time, I just want to share what we can offer you. The Indian Army is not merely a customer, it is a strategic partner with the defense industry. So here, the Army can offer you a vast repository of operational knowledge and user experience. When we share a problem statement with you, we'll give you the access to the real world problem statements and capability gaps. We will assist you in your endeavor towards reverse engineering. We'll provide you the designs, we'll provide you the drawings, we'll provide you the technical know-how, how to go about it. Even after that, we'll assist you in carrying out the trials and certify that equipment. Once the equipment is certified, when the equipment is proved, when it's passed the triple FT, you can be marked as the source for that particular equipment. We can give you long-term demand visibility for that particular requirement for that particular assembly or sub-assembly. So in this, there is a need to have a joint capability creation. As an army alone, we cannot bridge this gap. That's why we are looking at you. We are looking at the industry, academia, and the startups and MSMEs. Together, we can build a system which is self-reliant. Now, in this regard, we have army-based workshops. We have 8 army-based workshops all over the country. These are the national assets. Now, each army-based workshop has got its own capability. They are a center of excellence for a particular type of equipment. And they have a plethora of knowledge and decades of experience and expertise in reverse engineering, quality assurance, metallurgy, maintenance, overhaul, and so on. Now, to exploit their potential, what we have done, earlier the Directorate of Indigenisation was located at Delhi. So, that was the only headquarters in the country and where one has to approach, though there are various means to approach. But to increase our reach to the industry, what we have done now, we have created nodal indigenization centers, NICs, all across the country, along with each army-based workshops. So there are now 8 NICs all over the country with the expertise in particular field, like our NIC with 505 army-based workshop. They have expertise in the A vehicles, that is T-90s and T-72s. Similarly, we have 506, that is Allahabad. It has expertise in armament systems. Then 510 with the air defense systems. 512 with the expertise in the BMPs and armor recovery vehicles. 515, which is there here in Bangalore, it has expertise in the aviation sector. And 509, basically the electronics, which looks after all the electronics. Both 509, which is in Agra, and 515, which is at Bangalore. Both have got specialization in the electronic systems, and they are looking after the indigenization of anything which has got electronics in it. So these are the 2 places where you can approach directly and share your expertise. So here the map shows where all we are located and how you can approach us. I have already told you which NIC looks after what equipment. Irrespective of that, if you are in that particular area and you have some other expertise also, still you can approach that NIC and they will guide you and they will connect you with the relevant NIC or with the headquarter DOI. And then we can guide you ahead. Now, what opportunity we offer you? Now, in any platform, DOI Army looks after all the equipment of the Indian Army, whether it is A vehicles, armament, specialist vehicles, electronics, communication. So, I have flashed few of the subsystems and the sub-assemblies on the slide, but this is not exhaustive. It is just give you an idea that if you have expertise in any of the system subsystems, you can approach us. We keep uploading the problem statements. In addition, if there is some capability which you are holding, you can approach us. We can tell you what kind of requirement we are having in what kind of system. In addition to the all mechanical assembly sub-assemblies, which I have listed here, there is a lot of requirement on the electronics and communication portion. Though we have attained a good amount of expertise in the mechanical subsystems, but still a lot of is required to be done in the electronics. In electronics, we are looking at the PCBs of various subsystems like radars, tanks, inertial navigation systems, radio frequency units, power amplifiers, diagnostic test equipments, and so on. Many cables are there. They are very, very complicated cables, which we are looking for the tanks, guns, missile systems, radars. So those challenges are also there. Now, all these equipment which I am talking about, most of the equipment are imported equipment. And that is the reason why we are looking at you, to indigenize all those spare parts so that we have a self-reliance in these systems. As I already brought out, that these systems are going to stay, and not going to stay for next 1 or 2 years. They are going to stay for next 10, 15, 20 years. So if you indigenize any of the part, sub-part or assembly, sub-assembly, the requirement will be there for years to come. It is not a one-time effort. As I said, we need to have expertise in the reverse engineering. We are looking for a industry support in this. They are critical spares. As rightly brought out, innovation is not always about creating something new, but finding a better way to build what matters. And this is what matters to us. There is a lot of advancement now in the industry, in the advanced manufacturing system, in the 3D printing and all, though we also have that capability within Army, but the capacity is not there. That's why we are looking at you. Our requirement is huge. The Army, our primary role is not manufacturing. So that's why we are looking at the industry to assist us in meeting our requirement. AI. Now these days, AI is there in everything, whether it is a predictive maintenance, failure prediction, inventory optimization, or fleet health management. Everywhere now we intend to use AI because it gives you a problem in advance which you are about to face. As brought out in the earlier sessions also, that it is very easy to generate data, and we are generating a lot of data. But how to use that data, that matters the most. Digital twins and condition monitoring, again, this is the latest thing. And again, if you have expertise in this, we are looking at it. Now, I have told you what we can offer you, but at the same time, what we expect from you. We are looking at the industry which can move beyond simple manufacturing and provide us the innovative solutions for the reverse engineering or for the indigenization as such. We expect you and we request you to invest in R&D, because it is not that you have to replicate the equipment. Even if you can't replicate or you can replicate, you must look at how you can enhance the facilities or the capability of that system. That is what we are looking at. The systems which we are using, many of the systems are 30 to 40 years old, and the technology is again very old. So I am not looking at that you replicate that sub-assembly or assembly and give it to me. I am looking at that you develop that sub-assembly. The form factor should be same, but it should have much more capability than it is having now. And it should be using the latest technology so that we can sustain and maintain that assembly and sub-assembly for next 15 to 20 years. Now, DPM 2025 has a lot of enabling provisions for the vendors, for the industry, for the startups, for the MSMEs. Few of these I have listed here on the view foil. Like LD is waived off for the genuine developers. EMD is not mandatory, that is to encourage wider participation. Single vendor tendering is permitted for critical and unique solutions. The PBG is only after you develop a successful prototype. The change management clause is there. that is for adaptive and evolving requirements. So it is not that whatever I have written in the RFP, that is final. It can be amended. The 100% payment is being ensured now within 30 days of the delivery. The option for advance payment is there. And also, the stage-wise payment is there. So all these benefits are there for the MSMEs, for the startups, for definitely big industries, they can absorb. But for the, I'm looking at more at the startups and the MSMEs. As General Mann has also gave out, there are a lot of success stories which through indigenization we have achieved. I am also flashing few of them. So this is all the indigenization of sub-assemblies, assemblies, spare parts. Recently, the utility portion of ARV has been indigenized, which was going on for last 3 to 4 years. Now with this, I must tell you that the innovation today is increasingly driven by the startups, MSMEs and academia. The young minds, they have the agility to come out with the creative solutions rapidly. And we must create an ecosystem where the soldiers, scientists, MSMEs, innovators, industry, they can work together seamlessly. So that's what we are looking at. The future, as we all know, belongs to a nation which can innovate, design, manufacture, and sustain the critical technologies, that too domestically. Also, the defense indigenization is not merely about the economic objective. We know that we have to maintain a balance between your economic interest and the national interest. So, at times, you must look at the national interest also, because there are many instances when somebody comes to us, he says, sir, I can indigenize this product. I have got the capability. But you first tell me, what is the MOQ you will give me? And how much quantity order you will give me? Let me tell you, my answer is, the first you develop that product. Definitely you will get an order. If you are the only one who can develop it, then order will go to you only. Of course, we are looking at the competitiveness, but at the same time, the national interest for us takes priority. The Indian Army stands ready to work shoulder to shoulder with industry, academia, and innovation partners. Today, now together we can transform the challenges into opportunities, dependence into self-reliance, and ideas into operational capabilities. And I am sure this conclave will become a catalyst for deeper partnership, faster innovation, and greater national capability. Thank you. Jain.
Thank you, Brigadier Alok Jain. I think you gave quite an insight into the indigenous requirements. I'll not dwell more on it because of the shortage of time. So now I invite the next panelist, Air Commodore K. Giri. Let me introduce him to you. He's an aeronautical engineering officer, an experience of about 32 years in the field of military aviation maintenance. And he is presently tenanting the appointment of Commandant of the Air Force Technical College here itself at Jalahali, Bangalore, which undertakes training for all aeronautical engineers in Air Force. And he has served at premier frontline bases and has a vast, in fact, operational experience in all the operations probably ever since he's been in service, right from Operation Vijay during Kargil, Op Prakram, which was that post-parliament attack, then operations post-Balakot strikes, and also on a key role during Op Sindoor. He's also had lateral association with the tenures with MOD and DRDO. And he's a postgraduate in combustion and propulsion technology from IIT Madras and holds 2 postgraduate degrees in management from Delhi University and Osmania. And he's presently pursuing his doctorate from IIT Kharagpur. And he's been trained by the US Air Force on weapons and ground safety, a certified reliability engineer by American Society for Quality, and he holds IPMA Level D certification in project management. And for his distinguished services, obviously he has been also awarded Vichis Seva Medal and several commendation cards, both from the Air Chief and the CNC of Strategic Forces Command. So I request you to please come over and deliver your talk.
Session Chair, co-panelists, distinguished delegates from the industry, ladies and gentlemen, a very good afternoon to all of you and Jai Hind. It's a privilege to represent the Indian Air Force at this summit here. Standing here in Bangalore, the tech heartbeat of our nation, I look around this auditorium and see the true architects of India's strategic future. This year's theme, Strategic Electronics for Modern Airfare, Intelligence-Driven and Tech-Powered, is not a marketing phrase. It is a fairly accurate description of where warfare has moved. Let me now begin with a stark reality from a maintenance and an operational engineering perspective. Modern air power is no longer defined solely by aerodynamic airframes or engine thrust. The platforms that decide outcomes today are rarely defined by a single weapon system. They are defined by electronics that sit inside, around, and above that system. That is the sensors that detect, the processors that fuse information, that networks that move it, the algorithms that compress the time between detection and decision. Surveillance and reconnaissance, electronic warfare, secure and resilient communication, and increasingly autonomous and AI-enabled systems are no longer now support functions. They are the battlefield's central nervous system. Therefore, today, air power is largely defined by silicon, software, and spectral dominance. For the Indian Air Force, and indeed for all the three services, this has a direct implication. Our operational edge depends as much on the electronic ecosystem behind our platforms and on the platforms. When a fighter pilot pulls 9G in a latest generation combat aircraft, or when an air defense controller tracks a low RCS drone 300 kilometers away, they are trusting an ultra-dense array of active electronically scanned arrays, military-grade microprocessors, high-frequency warning receivers, and jam-resistant software-defined radios. If those electronic components are imported, our strategic autonomy is borrowed. If those printed circuit boards carry hidden vulnerabilities or foreign obsolescence timelines, our operational readiness remains at the mercy of global geopolitical supply chain shifts. A radar that cannot be upgraded fast enough, a sensor that depends on a single foreign source, a software which we cannot modify on our own timeline. Each of these is an operational vulnerability, and not merely a procurement inconvenience. So now allow me to draw out three shifts that I believe everyone in this room, whether you sit in uniform, in a DPSU or in a startup, needs to be designing for and not merely reacting to. From platforms to networks. The unit of advantage is no longer a single aircraft, ship, or a gun, but the network of sensors, shooters, and decision makers around it. A system that cannot share data securely and in real time, however capable in isolation, is already much behind. This is why secure, interoperable, low latency communication backbones deserve as much investment as the sensors themselves. From manned to mixed, unmanned and autonomous systems in the air, land, or sea are moving from the periphery of force structures to the core of them. The cost asymmetry they offer and the ability to absorb risk without risking a crew is now reshaping how every service thinks about force design. India's drone and autonomous systems industry, much of it represented on this exhibition floor, sits at the center of that shift. The next one is from the hardware superiority to spectrum and software dominance. EW, the contest to see, jam, deceive, and protect across the electromagnetic spectrum, increasingly decides engagements before a shot is fired. And because EW and enabled systems are defined as much by software and algorithms as by the hardware, the ability to update, retrain, and patch our own systems has become a frontline capability in its own right. None of these three shifts can be addressed by import alone, however capable the imported system is. They require an ecosystem that can be touched, modified, reiterated locally, which brings me why self-reliance is, in my view, not a parallel policy objective, but the precondition to staying current on all the three. Against that honest reckoning of the challenges, I want to be equally honest about the suite of self-reliance measures that has already been delivered, because the numbers and the programs are substantial and they deserve to be named rather than be treated as a background noise. India's total defense production value has grown to an all-time high of 1.7 lakh crores today, which is about 15% growth over the previous year and an overall about 110% increase since 2020. The growth over the previous years and all an overall 110% increase. The Defense Acquisition Procedure 2020, the 5 positive indigenization lists, each from the Department of Defense and Defense Production, that mandate domestic sourcing over 5,000 components. The IDEX framework, which has drawn in over 600 startups and MSMEs against 500 plus problem statements. The Aditi scheme that provides a grant support of up to 25 crores. All these are not only operational, aspirational statements. They represent a structural rewiring of how India buys, builds, and absorbs defense technology. For every company exhibiting at this summit, that rewiring translates into a market that is real, funded, and actively looking for Indian alternatives to what it previously imported. From the Indian Air Force perspective, the consequences of this ecosystem buildup are now visible and operational and not merely promised. Nearly 75% of the Indian Air Force's capital procurement expenditure has been earmarked purely from the domestic industry, a figure that would have been unthinkable a decade ago. The Tejas LCA Mark I program, which contracts for 83 aircraft and further 97 signed in the recent, is becoming the backbone of our indigenous fleet. The platform that carries indigenous Astra beyond visual range, the DRDO developed Uttam AESA radar, which enters standard fit, is progressively replacing the interim foreign radar fit with the indigenous electronic warfare suite, following the same deepening trajectory. Each of these represents the DRDO and the DPSU capability that was, not long ago, sourced entirely from abroad. The next is our Su-30 MKA fleet, which is undergoing an indigenous upgrade that will equip these aircraft with DRDO's Virupaksha ESA radar and indigenous high-band jammer prod and Dhruti, the radar warning receiver, all replacing previously imported EW and sensor fits with domestically designed and manufactured equivalents. The Netra airborne early warning system and control platform, the Akash new generation surface-to-air missiles, and the family of ground-based radars, which is the Ashwini, Arudra, and the Aslesha, are active or advancing force multipliers, each representing a domain where India now holds its own proprietary rather than paying a foreign license to use it. The secure C4 ISR networks, systems like the integrated air command and control systems, the indigenous software-defined radios, are ensuring jam-resistant, high-bandwidth data links across not only the Air Force but the Army and the Navy as well, which are powered by Indian cryptographic hardware and communication chips. All these are not isolated achievements. They form a pattern, and the pattern is one of a force that is building genuine depth in indigenous capability, program by program and subsystem by subsystem. However, As an Air Force engineering officer, I must offer a candid observation. We cannot satisfy ourselves with platform level indigenization while remaining dependent on the component level imports. If we integrate an indigenous airframe and an indigenous radar, but source the underlying gallium arsenide and gallium nitride MMICs, high precision clock oscillators, and aviation grade connectors all from the foreign OEMs, we have achieved only assembly level self-reliance and not technological superiority or sovereignty. The Indian armed forces are shifting our focus deep and down the supply chain. We are executing a deliberate, synchronized, tri-service transition from LRU, that is line replaceable unit level, down to shop replaceable units, that is the SRU, and even the electronic component level indigenization. Why? Because when supply chains choke during a crisis, foreign OEMs do not just delay component shipments. They withhold component level repair data, software drivers, and chip architecture. Therefore, component level indigenization is our insurance against supply chain blockades. How is the Indian Air Force operationalizing this shift on ground? Our indigenization engine operates thoroughly into a deeply structured network built around our base repair depots, our central indigenization and manufacturing depot, and our nodal technology centers. To give industry partners in this room a clear map of where to engage, let me break down our engineering depots. The 12 BRD, which is in Delhi, specializes on the electronic warfare, indigenizing radar warning receivers, jammer pods, and chaff flare dispenser controls. These 7 BRD and 13 BRD, again both at Delhi, spearhead ground radars, air defense communications, and navigation aids, focusing on RF power amplifiers, phase shifters, and digital signal processing boards. The 4 BRD at Kanpur and the 11 BRD at Nasik focus on aero engines and fighter avionics, driving the replacement of legacy flight control computers, multifunction displays, and power supply units. The 9 BRD at Pune focuses on airborne communication and navigation systems. To bridge the gap between operational military requirements and cutting-edge engineering research, the Indian Air Force has established nodal technology centers co-located with top IITs and IAC. Through these NTCs and BRDs, we don't just hand over industry, just a broken foreign part, and say, copy this. We open our technical specifications, we provide test bench environments, we offer flight test facilities, and guide you through the process of airworthiness certification. Once the local certification is awarded by our depot self-reliance committees or the SEMILAC, we commit to sustained vendor orders, providing operational visibility for years. If you look at the Ministry of Defense region portal, the Indian Air Force alone has hosted hundreds of high-value ex-import electronic items. We are actively seeking Indian industry partners to indigenize military-grade active and passive components. The details are as shown. Optoelectronics and display systems, power electronics, RF and microwave modules. To our industry leaders, Tier 1 suppliers, MSMEs, and semiconductor startups present at the summit today, the armed forces are opening doors wider than ever before. But we solicit these commitments from you in return. Firstly, uncompromising quality and reliability. In civil applications, an electronic chip failure means just a dropped call or a rebooted screen. In aerospace electronics, a component failure at Mach 1.5 or during an all-weather night strike means a potential loss of a precious life and a strategic asset. Therefore, aviation grade standards, MIL standards, environmental testing and screening are non-negotiable. The next is speed of execution. Technology in the electronic obsolesces every 18 to 24 months, as you all know. If an indigenization project takes 6 years from the AON to flight trial, the chip we indigenize will be obsolete before it reaches the squadron. The next is the focus on MRO and life cycle support. Don't just build a component. partner with our base repair depots to set up indigenous repair and overhaul facilities. True self-reliance means not only production, it means that we can maintain, we can repair and upgrade our avionics inside India for the entire 30 to 40-year life cycle of an aircraft fleet. Design for the user and much early. The most useful defense electronic products are those co-developed with the forces from the concept stage, not adapted afterwards. Vendor development interactions of the kind this summit hosts with the DPSUs and industry partners are exactly the right forum to start that conversation. Military grade is a different standard, not a marginally harder one. Ruggedization, EMI, EMC compliance, environmental qualification, and a long-term sustainment support are all not optional extras. They are what separates a commercial product from a deployable product. The next is the impetus on components and not systems. India has made faster progress at the systems integration level than at the component and the semiconductor level. Industry that is willing to invest in the less glamorous, harder problem of indigenous components, connectors, RF chains and chipsets will find that demand and policy support, which is not only going to grow. The next request of ours is to treat supply chain security as a design parameter. Where your subsystem components come from, who has access to your firmware, and how your product behaves if a single foreign supplier is withdrawn. These questions belong in the design review and not as an afterthought once a system is already fielded. The components that build this discipline in early will find it easier, not harder to win defense business over time. Ladies and gentlemen, strategic electronics is the invisible backbone of modern war fighting. When an Indian jet fighter patrols our skies, when a naval destroyer monitors the sea lanes, or when an army air defense unit secures our borders, every circuit board inside those systems should proudly bear the stamp, made in India, designed in India, and tested in India. The Indian Air Force stands fully committed to walking shoulder to shoulder with ELCINA, our DPSUs, our private industry partners, the academia and the dynamic startups. Our depots are open to you. Our test beds are ready for you. Our operational requirements are clear and stipulated. So let us use this summit as a springboard to move from importing strategic chips to designing, fabricating, and exporting world-class defense electronics. Together, let us build a secure, resilient, and a truly self-reliant Atmanirbhar defense ecosystem for a Viksit Bharat. Jai Hind. Thank you.
Thank you, Giri. With that, now I would like to introduce the last panelist, Captain Sanjay Sharma, a veteran from Indian Navy. He is a naval technocrat, systems engineer, and operations leader with 35 years service in the Indian Navy. He holds a Master of Engineering in Electronics and Communications Engineering with specialization in VLSI technology from IIT Roorkee, along with a BTech in Electrical Engineering and a BSc in Electronics. He has extensive experience across defense electronics, reliability engineering, quality assurance, systems engineering, project management, naval systems induction, and strategic infrastructure development. And he is a certified reliability professional, software quality professional, software test manager, and ISO 9001 lead auditor. Also for his distinguished services, he has received certain commendations from both Chief of the Naval Staff and DGK. He is currently the managing partner of Punya Pramana QD Advisors. So I'll request you to please start with your talk.
Indian Navy, the last but not the least. So, I have a question for the audience. How many of you play or have played cricket? Please raise your hands. So, I count about 30. Now, how many of you play football? I see 1/3 the numbers. So, no wonder the two most populous nations on the planet they didn't reach the World Cup finals. And ladies and gentlemen, Indian Navy is in the business of playing football. We efficiently finish off things in 90 minutes. We run at the speed of the ball. We don't avoid going out of the boundary. We believe in scoring goals and winning by that. And finally, we have shifted the play field from the circular to the rectangular, what Silicon is undergoing now. So thank you very much. It's been 4 years since I hung my uniform, and nice of General Chandele and Raju Bhai to have given me this opportunity for the second time after I had the pleasure and privilege to address you in 2022. My presentation is that I think it's taking a bit. I will not bombard you with technical jargon, but my message is that mainly everything is online. That's a huge productivity multiplier. Our Chief Minister mentioned that we have to become self-reliant, and he gave you a small hint that look beyond Bangalore. The government of Karnataka is giving you a lot of incentives to move beyond Bangalore. So now I see that my theme is that let's move to the crux of the problem if we have to be a great nation. Honorable Chairman of this session, the ELCINA presidents and past presidents, the organizing staff, distinguished technocrats, IC servicemen, and a lot of young faces. Putting things in perspective, India has a coastline of 7,500 kilometers and an EEZ of 2 million square kilometers. We are endowed with abundant oceanic wealth and large number of islands and a vast seabed area waiting to be explored. Do you know that 97% of our international trade happens through the sea route by volume and 70% by value? It is therefore imperative that your Navy is strong. Our Navy was among the few nations escorting oil tankers a few weeks back through the Strait of Hormuz in the ongoing Iran conflict. But your Navy was so strong during Kargil war that the enemy didn't dare face us. There's no way to hide on the open sea. Let me start with the government's vision of the Amrit Kal vision of 2047. Can somebody from the audience tell me what is the bottom line of this mission in terms of money? We are looking at a $30 trillion economy. And this, so far as the Navy is concerned, from today's around 200 warships to around 400, which implies a staggering 1.78 lakh crore has been earmarked by the government. This blueprint has been shared with the general public in the form of an indigenization roadmap document or a blueprint called Swavlamban, which is in its version 4. Now, where is the challenge? We have mastered the float and the move category, but we are only at 50% fight capability. That means only 50% of the components that go into our naval systems are indigenized. But there is an improvement. Last time I spoke, we were at 30%. Today we are 50%. So ELCINA has contributed a lot in that way. So my compliments to you all, ELCINA members and industries participating. Now see, what is the indigenization demand? This is a graphic representation. If you see, we have made our requirements public, and instead of waiting for lengthy tender documents, component manufacturers now have been provided a clear 5 to 10 years perspective and a roadmap of the exact sensors, seekers and communication hardware needed by the Swavlamban roadmap. Look at the first two focus areas, weapon fire control and sensors. These are the primary bottleneck in Indian missile and naval gun production, which is not steel or propellant. It is the electronic seeker in the nose cone and the fire control computer. On the sensor side, every modern warship requires thousands of gallium nitride TR, transmit receive modules, for ASA radar, which our chairman mentioned during his speech, and piezoelectric ceramics for sonars. Localizing these component level elements is where the highest margins are there waiting for you in the industry. But this calls for IP, not just TOT. The next, moving to communication and frontier tech, Navy needs software-defined radios. But where are we stuck? We are stuck because they depend on certain very crucial components called FPGAs, which again is dependent on silicon or modern semiconductors. My Army and Air Force counterparts have already covered the communication part, so I'm not repeating it. We have filled order books, but what is facing us in the global component blockades are hidden software kill switches. And the other evil is of the rapid obsolescence cycles. Defense systems are designed to operate for 20 to 30 years, but the chip industry is going at a fast gallop of 3 years to 5 years, leaving you all the enormous task to do the upgrade quickly and with agility, but now it is looking increasingly possible. Let's see the hard truths, which is being taken care of by the strategic enablers, which has already been covered except for the Swavlamban part and the semicon part. Here you will see that the most important part here is the Semicon 2.0, which was just announced a week back by the government on 15th of July, wherein they have given a very clear vision of what we are planning to do. For many years, we had a deep dependency on foreign silicon, specifically high reliability FPGAs, RF semiconductor dies, and proprietary electronic design automation EDA software tools. The government now has updated the mission with the focus in Semicon 2.0, with a 1.25 trillion allocation in rupees. The updated mission focus is on upstream machines and material pillar and compound semiconductor packaging called ATMP and OSAT. These are two very important terms. One is ATMP means we are getting the finished chip, obviously manufactured abroad, and OSAT is outsourced semiconductor acceptance testing. This is where a big opportunity is waiting for us, where we get the die or the wafer, we program it with our IP, and thereafter we package it and market. So the end control, user control is with us. So this is one emerging, immediate opportunity available to all of you. Those who would like to address the problem at the grassroots level is sourcing and manufacturing the chips. Let's have a look on what items are getting imported with the perspective of Bharat Electronics. The last column on the right specifies the items that we are importing from abroad. And these are, if manufactured in India, can lower the cost. I'm going by my experience 4 years ago, anywhere between 10 to 100 times. So if something costed 1 rupee, we are buying it for 100 or 10 rupees from abroad. Now, Rajuji will not give me tea if I don't talk about AI. Rajuji? Now, AI, by the way, this presentation has been made on AI, on Google Gemini. I kept talking, and the paid subscription, that made this presentation, and it didn't open here. So I had to struggle for another 30 minutes during lunchtime. So AI, please, cannot be trusted. It is that HI or human intelligence which is driving AI. But at the same time, it offers numerous advantages. The time I would have spent adjusting fonts here and there, thinking what to write, AI did it for me, and it did a better job. So we have to use our HI to decide what AI should do for us. So here, in what Navy has, homed on to, is to facilitate the AESA radar, which was mentioned by my colleagues, in getting those FPGAs and GPUs. We are a little way off for GPUs, but we are very close to FPGAs. Also, another challenge area, since Navy operates underwater, is throwing out the sound waves using transducers. Transducer elements are nothing but, used to be piezoelectric crystals. Now we have graduated to modern material, and these are again available, being imported at 20 times the cost than what we can possibly manufacture in India, and put it in the sonar electronics. Now, how does AI benefit us? AI is practically benefiting us in the electronic sector, firstly on the product side, embedding the AI algorithm into hardware like an acoustic processing board, moves up the value chain from low-cost contract assemblers to high-margin IP owners. Secondly, you know that defense requires zero defect rates on the factory as well as hopefully on the field. The AI-driven automatic optical inspection and digital twin simulations cut down the qualification times and boost factory yields. Thus, the AI levels the playing field for those who are agile and playing football. Coming to my wrapping up and the conclusion part, the Indian Navy's published requirements give us a very crystal clear playbook. The growth plan for ELCINA members is to move up the value chain from standard assembly to indigenous defense IP. By leveraging the IDEX grants and state ESDM schemes, companies can co-develop these high-demand components and lock in long-term procurement orders for the next decade. Now, I will come on to what are the specific schemes and advantages that Karnataka government is giving us. This is, I've already spoken this. Did you know that scaling your electronics manufacturing inside Bengaluru right now means fighting over saturated infrastructure and skyrocketing operational costs? There's a smarter way. By expanding your footprint under Karnataka's Beyond Bengaluru mission, you can drastically cut your capex while maximizing state support. Under the current ESDM policy framework, ESDM is Electronic System Design and Manufacturing, the Karnataka government has encouraged setting up fast-moving electronic hubs like in Mysore or Mysuru and Hubli Dharwad axis. This unlocks you a massive 25% capital subsidy on land and 20% capex assistance on plant and machinery. On top of that, you get a 1% production linked incentive PLI on your annual turnover for 5 years, combined with a 100% electricity duty exemption. These are mouth-watering incentives. So we run a defense consultancy where we offer you seamless transition into these high growth zones, managing everything from compliance to unlocking the maximum government subsidies that you are entitled to. Finally, please note that thanks to you, some of you are present, defense electronics are no longer a low volume burden. Thanks to dual use and global and the possibility of global defense exports, presently at around approximately 40 crores, products designed for the Indian Navy now have a vibrant B2B pipeline exporting to over 80 countries. If startups can capture this algorithmic and design IP via programs like the DLI scheme, while challenging the major conglomerates to leverage Silicon 2.0 mission and with subsidies, then we can make a physical compound chip fabs that India desperately needs. The focus on dual-use technology parallelly should not be ignored. Moment you are exploring an Indian defense requirement, look at the civil use, how to make humanity more convenient and better. In conclusion, let us stop just designing the brains and skeletons of our warships. It is time we started manufacturing the silicon they run on, or even chip testing, followed by packaging to open up an ocean of electronic system possibilities. Dear ELCINA members, the future isn't just about manufacturing passive PCBs. It is about AI-ready, ruggedized electronic subsystems, and then, after these silicon baby steps, graduate to a full system capability. So with that, my goal is scored. I hope to see the next generation billionaires from one of you young faces that I see here. And I now hand over back to the chair. Sir, I have finished under
Thank
your
you.
timeline
Thank
of
you.
15
Thank you.
minutes.
Yeah, thank you, Captain Sharma. Yeah. We have, as a panel, overshot our time by about 8 minutes. So, should the MC permit, we can take one odd question. Otherwise, it's per you. Okay. Yeah, question from the audience. Yeah, that's it, that corner. Please. Somebody can give him a mic, please.
So I am Dr. K. Bhaskar from Rajalakshmi Engineering College, Chennai. So from your statements, it is Indian defense system, army system, everybody is requiring academia support. But how private institutions can play a role in it? In what way the private institutions can come forward, how to link?
Okay, okay. Yeah, I got your question. You see, all those documents which I showed you, which we have online available, or compendium of problem definition statements, compendium of technological challenges, please respond to them. There's a proper procedure given in those documents itself, the guidelines given in them. And like I showed you for our CPDS, we had 25% academia respondents and 75% industry. Then we go through a selection process. Even if it is private, they are given the developmental project. As of today, we have got about nearly about 100 crore plus being funded by the army with the private academia through this process. Any more questions?
There is one more way. You can encourage your students to join the Army, Navy or Air Force, and they will come back to your institution and encourage your students to join back. It's like what we used to call avalanche multiplication. Okay?
Okay. One more question. Last question.
Gentlemen, this is Brigadier Muthukumar, and
Sir, be louder, please. No, it's working, but be louder.
Gentlemen, this is Brigadier Muthukumar, as you are aware. As always, great presentation. Thank you. Question is that you actually, I am surprised because every time I was interested in following a presentation. This time you have tried to yourself ask a few questions and flash a few slides. One of them was the NCNC thing. Many people nowadays upfront come and say in academia interactions, in Pravartak, in number of places, no sir, no NCNC, some other way. There are no free lunches, there are no easy ways. NCNC is a tough way. The equipment undergoes degradation. All of you will appreciate. But then, according to me, that old good NCNC, like you are aware, the snow cutters and all came through that route. So you flashed it well. Just can you, for the benefit of audience, because 3 or 4 asked me, flash out as to how a pro bono NCNC will find a pathway in the current setup because you have already shown gaps.
Okay. Fine, but because of shortage of time, I did not elaborate on that aspect. But basically, when the industry has any product available, or product, and you are ready to offer it for no cost, no commitment demonstration, please do write to Army Design Bureau. Just Google Army Design Bureau and you will land onto our web page, which is on the Indian Army website. And shortly we are going to launch our own separate website for the Army Design Bureau. You'll get the contact details. Please send your proposal on that. Once the proposal comes, our subject matter experts compare it, see it, that okay, is it something better than what we are already getting? If yes, then they do recommend it for the NCNC demonstration. And then we request the firm to take their equipment to that particular envisaged area of operations. You operate the equipment over there. Now, there's a difference between NCNC demo and NCNC trial. Generally, people go by that first phrase NCNC and not the second part of it, the demo and the trial, the difference between the two. A trial is conducted against a procurement process, against an RFP for those vendors who have cleared the TEC and they are into the trial stage now. And there are, so whether the outcome of that is concerned, the results are concerned, there are no shades of gray. It's either you are compliant or you are non-compliant. If the weight is required to be less than 2 kgs, if you are 2.001 kg, you are non-compliant in that. It's as simple as that. So there are no shades of gray in it. Whereas on the other side, the NCNC demo is not against any procurement case as such. It's not against any RFP. It's not against any QR. What we are validating in that is only what the industry has claimed, that this is the capability of my equipment. We validate that. Now the outcome. You may not be able to achieve that capability. In many cases it happens, while the industry claims something, but the capability actually achieved is lower than that. Doesn't matter. This is where shades of gray comes in. Because in case that capability, whatever is achieved is even lower than what you had claimed, but it is adding to our operational capability, it is adding to our present capability, we may go in for the procurement. And that is how what I had shown you on that one slide are all those equipment which are not part of our annual acquisition plans, but we saw some capability, may not be perfect solutions, but yes, adding to our value. So that is how this NCNC demo, once it is, you offer the equipment, we get the visibility that what is available with the industry. If required to be procured immediately, for example, in terms of emergency procurements, which have happened over these last 3-4 years, or even in future to initiate our procurement case, where the industry stands, what the capability industry has, and on the other hand, for the industry, because you get to know how well is your equipment performing. And also, like I mentioned, with the troops on ground who are giving you the feedback, we receive the product improvements suggested by the conducting unit and the formation, which are shared with then the developing agency whose equipment has undergone those NCNC demos. Now it is up to him, because of it being NCNC, whether they want to improve further or not. And many people do further improve and then again offer it. It goes into that cycle. So that is how it actually leads to that collaborative development also. And finally, will find ways somewhere or the other into procurement. Thank you.
Let's give Major General C.S. Mann a huge round of applause. And to all our panelists, may I now request Mr. Sanjeev Narayan, past president of ELCINA, to please join us on the stage to hand over the memento.
Shall I? Hello. Yeah, sir. Regarding NCNC, General Mann has covered the platform-centric procurement. I'll cover the sub-assemblies or assemblies or spares. So when we float RFI, and if you have a ready-made solution available, or you have developed that part, or you are in the process of developing that part, you can offer it to us on NCNC basis. Now you said it is a difficult thing. No, it is not a difficult. It is the easiest way. It is the fastest way. Because you are not now competing with anybody. You have a direct approach route towards us. You offer that equipment to us. We put it under trials. We verify your credentials. We put it under trials. If it passes, we source mark you. Once you are source marked, then procurement is through, again, open route. So that is the NCNC trial. So no commitment, no cost. So that's it.
Once again, thank you to our session chair, the panelists once again for sharing their ideas, the views, the perspectives on tri-service plans for self-reliance. Can we give a huge round of applause for Major General C.S. Mann? May I also request Mr. T. Vasu, past president of ELCINA, to please join us on the stage. Can we give a warm round of applause for Air Commodore K. Giri, VSM, Commandant, Air Force Technical College. Yes, sure.
just make one comment here. Way back 16 years ago, we were seeing only the big wigs in the exhibition hall, but now I see so many startup companies and so many products and so many youngsters. Most of them, 95% of them, I don't even understand. So that is the way ELCINA has brought up this people together, youngsters, startup in this. I'm so happy to say that, just sharing the view.
Captain Sanjay Sharma, retired Indian Navy with us. Let's give a warm round of applause, everybody together. Yeah, that was amazing. Thank you. Definitely. Brigadier Alok Jain, SM, DTE of Indigenisation, Indian Army.
So kindly come together for a group photograph of the panel. And thank you to all the wonderful speakers and all the officials on the dais. So thank you so much. Just a quick announcement. We have a short, MOU signing ceremony here with Electronic Sector Skill Council. So we request you to kindly stay back for that. But another important announcement is that we have one session on legal strategies for the Indian defense sector. Legal strategies for India's defense sector. This is a parallel session which is happening in the hall next to us. And that will be led by Lieutenant General Sanjay Verma, on behalf of SK Singhi and partners. So those who are interested to learn about that, we request you to kindly join there, and in the meantime, we will go ahead with the MOU signing ceremony here. So ESSCI team, can I please request you to come on stage? Mr. Madhvendra Singh, please. You please take over and you please kindly, we'll do the needful. Thank you. Once again, there is a session on legal strategies for India's defense sector conducted by Lieutenant General Sanjay Verma on behalf of SK Singhi and partners in the hall right next to us. It is where all the vendor development sessions are happening. Those who are interested may kindly join.
May I now request Electronic Sector Skills Council of India CEO, Mr. Madhvendra Singh, to please join us on the stage. A council promoted by ELCINA and Alliance University for Skill Development in Electronics System and Manufacturer. Kindly come forward for the exchange of MOU for Alliance University. Can we give a warm round of applause, everybody, together?
Exchange between the Electronic Sector Skill Council of India, a skill development council promoted by ELCINA, and by Quantum Pulse, an organization based in Chennai for skill development in higher-end job roles in semiconductor and ESDM sector. So on stage we have Mr. Madhvendra Singh, Chief Executive Officer of the Electronic Sector Skill Council, and Mr. Satyanarayan, the Director Operations of Quantum Pulse.
request Sri Ishwar College of Engineering, Coimbatore, Dr. Sudha Mohan Ram, Principal, to please join us on the stage. Skill development. Silicon chip for skill development in semiconductor to please join us for collaborating with ELCINA.
This collaboration between silicon chip and the electronic. So there was a MOU exchange. So this collaboration between silicon chip and electronic sector skill council of India seeks to develop a skilled workforce for the semiconductor industry, especially in semiconductor design and ATMP. We're very happy to announce the collaboration between the Electronic Sector Skill Council of India and Silicon Chips.
On behalf of ELCINA, I sincerely thank all distinguished dignitaries, speakers, delegates, partners, and participants for your valuable presence and contribution. We also thank our organizing team for their tireless efforts. So we look forward to welcoming you tomorrow for day 2. And thank you. Have a wonderful evening and Jai Hind.